Hello everyone, I'm Shivani and welcome to Civil Series. First question is, it is the extension of one or more course of bricks from the face of wall. These are the options. In these options, first is coping. Coping is the topmost part of any building component, and coping is used to seepage of water, to prevent the seepage of water. And then next to coping there is cornice. Cornice is formed by ornamental cores in the junction of wall and ceiling. Then immediately below the cornice there is frieze. Frieze is formed by stone and along with the external face of wall. Then next to frieze is corbel, and corbel is the extension of one or more cores of a brick from the face of wall, and corbel is also used to support the roof truss, beam and weather sheds. So option for this first question is corbel. So this is the appropriate figure related to component of building to address every part of building. And here in this figure there is corbel, cornice, frieze and coping. So observe this figure and remember the names related to the figure, because sometimes they ask the fill in the blanks in this figure. So you need to remember this figure with the name and part of building components. Then question number second, the compressive strength of ordinary Portland cement proportion is 1:3. That cement mortar cube after 7 days test should not be less than. Okay, so here they ask a compressive strength after 7 days, and that should not be less than. Okay, so compressive strength after 7 days should not be less than 17.50 Newton per mm square. And in case of 3 days, means the cement mortar cube after 3 days test should not be less than 11.50. So remember this also, after 3 days the strength will be, or the strength should not be less than 11.50 Newton per mm square, and after 7 days the compressive strength should not be less than 17.5 Newton per mm square. So option number B is correct. Then third, attrition test on stone is performed. And this test is performed to determine the rate of wear of stone due to grinding action under traffic. And that attrition test indicates the resisting power of stones against the grinding action under the traffic. Okay, so it's easy to remember that attrition test is related to wear of stone. Okay, so here the option number fourth or last option is correct. Then next question is, which of the following is igneous rock? These are the options. Igneous rock is the rock formed by solidification of molten mass. There are three type of rocks. First is igneous rock, second is sedimentary rock, and third is metamorphic rock. Igneous rock is formed by solidification of molten mass, sedimentary rock is formed by deposition, and metamorphic rock is formed by pressure and heat. Okay, so here they ask the example related to igneous rock. So these are the some examples related to igneous rock. In that, first is basalt, then pumice, then obsidian, then rhyolite, then scoria, then diacite, then granite, gabbro, and diabase, diorite, pegmatite, and peridot. Okay, so these are the few examples related to igneous rock. In that, the option number first is correct. Granite is the igneous rock. Then option number B or option B is marble, which is metamorphic rock, and sandstone and limestone is a sedimentary rock. Then next question is related to mixed proportion, and this question is from BMC 2019 exam. Mixed proportion questions are mostly asked in these year exam. So you remember the chart related to mixed proportions, and so you easily get the marks related to the mixed proportions. So here they ask the M25 mixed proportion. So this is the chart related to the mixed proportion. In that first, uh, So it is easy to remember. Just remember that the column first, that M5, M7.5, and after that there is a difference of 5. Okay, M5, then M7.5, and then M10, 15, 20, 25, 30, 35, 40. Okay, in case of ratios, start with 5, then 4, 3, 2, 1.5, 1, 0.75, zero point 0.5, and 0.25. Just double the number. 5, 10, 4, 8, 3, 6, 2, 4, 1.53, 1, 2, 0.75, 1.5, 0.51, and 0.25, zero point 0.5. Okay, so this is the mixed proportion, and for the M25, the value of mixed proportion is 1 is to 1 is to 2. So option number 4, D, is correct. Then same question related to mixed proportion for M15. So for M15, the ratio is 1 is to 2 is to 4. Then next question, when bending moment diagram changes its sign, that point is called as. In case of bending moment, that point is point of contraflexure. So option number A is correct. And if the shear force diagram changes its sign, then that point is point of contra shear. Okay, point of contra shear in case of shear force, and point of contraflexure in case of bending moment, when they change its sign from positive to negative or from negative to positive. Then next question, relation between equivalent length and actual length when one end is fixed and another end is hinged. Okay, so for this equivalent length there is a chart, and there are four conditions related to the supports. So here first condition is both ends are hinged. So LE is equals to L when both ends are hinged. Then both ends are fixed. Then LE means effective length is equals to L by 2 when one end is fixed and another end is hinged. So this is the question, that LE is equals to L by root 2. So here LE is the effective length and capital L is the actual length. Relation between LE and L is L equals to 1 by root 2. So here option number A is correct. And remaining condition is one end is fixed and another one is free, then effective length is equals to twice of actual length. Then next question is, which of the formula is correct? So the formula for partial or factor of safety, the formula for factor of safety is yield stress divided by working stress. Option B is correct. Next question is the value of partial safety factor for steel. The partial safety factor for steel is 1.15. 1.15, option B is correct. If they ask partial safety factor for concrete, then the answer is 1.5. And the partial safety factor is that value which indicates the strength related to concrete and steel. As we compare the strength of concrete and steel, steel has a more strength than concrete. So for steel there is a less partial safety factor, and for concrete there is more partial safety factor. The next is, which of the following is the limiting compressive strain value of concrete in limit state method? So the value is 0.0035. Option B is correct. Then next, if the quadrantal bearing system of line is south 30 west, then what is the whole circle bearing? Okay, so there are two types. First is whole circle bearing and second is reduced bearing. In case of whole circle bearing, the angles are measured from north pole, and in case of reduced bearing, the angles are measured from north and south pole. Okay, north and south pole. Then whole circle bearing, the angles are 360 degree, and in case of reduced bearing, the angles are 90 degree. Okay, major angle is from 90 degree, and this kind of pattern is related to reduced bearing. So here they give a reduced bearing. Reduced bearing is also called as a quadrantal bearing. Okay. This is the axis, and here they give the 30-degree angle. So this is north, south, east and west. Okay, so here the angle is southwest 30-degree. So this is 30-degree, and for whole circle bearing we need to add the value from north pole. So from north pole to south pole the value is 180-degree. So 180 plus 30 is 210. So whole circle bearing is 210-degree. Option B is correct. Then 13. In tachyometer, one is multiplying constant and other one is additive constant. Option A is correct. Then next question, an imaginary line or a line on a map joining the points on the earth's surface at which the magnetic declination is same is called. Okay, so magnetic declination is the angle between true bearing and magnetic bearing. And second concept is deep. Deep is the angle of horizontal surface and magnetic needle. Okay, so if the magnetic declination is same, then that line is isogonic line, and if the magnetic declination is zero, then that line is the agonic line. Okay, same concept is related to the deep. If that deep is zero, then the line is aclinic line, and if that deep is same, then that line is isoclinic line. And that tie line and base line in option number C and D are related to the chaining, that the baseline, tie line are used to check the surface area. Option number B is correct. Then 15, the foundation whose depth is considerably greater than its width is called as deep foundation. Option D is correct. Then 16, ideal transition curve is clothoid. Option A is correct. Then question 17, recommended slump of concrete for a road construction is, that road construction slump is 20 to 40 mm. Then what is the range of cobalt scale for drinking water? That range is 10 to 20 ppm. 10 to 20 ppm is the cobalt scale for drinking water. Then next question, converting domestic sewage into small packets of 6-inch length and 1-inch diameter is called. Domestic sewage into small packets of 6-inch length and 1-inch diameter is called as the palletization. Then next, the maximum permissible chlorine content for public supplies should be between, that should be between 0.1 to 0.2 ppm parts per million for the permissible chlorine content. Next question is 50 ppm means which hardness? Okay, so these are the option, and for the hardness there is one chart. This is the chart. In that first column is related to the range of hardness, and second is related to the kind of water. Okay, for 0 to 55 mg per liter there is a soft water. Then for 56 to 100 slightly hard water. Then 101 to 200 moderately hard water. Then next 201 to 300 there is very hard water. Okay, so again repeat again, 0 to 55 soft water, 56 to 100 slightly hard, 101 to 200 moderately hard, and 201 to 300 very hard. This is very important chart, remember this. Okay, so the answer is soft. Option A is correct. Then next, if the span of bridge is 27 meter, then bridge is termed as. Okay, so there are three type of range or three kind of range. First is up to the 6-meter span called as culvert. Then next, the span is up to 60 meter. Then the bridge is minor bridge. Then 60 to 120 meter, the bridge is major bridge. So option number A is correct, minor bridge. Then last question is, which of the following is not a part of bridge superstructure? Okay, so these are the option. Superstructure means the part which is above the ground, and pier is the part which is below the ground. So the option A is correct here. This is the substructure part. So option A is correct. And first question, the maximum stress that can be applied to a material for an infinite number of cycles of repeated stress without causing failure is called as. For infinite number of cycles without causing failure is called as endurance limit. Endurance limit जैसे ही और एक टर्म होती है उसे कहते हैं fatigue, but fatigue is with specified number of cycle and endurance limit is with the infinite number of cycles. So option D is correct here. So option D is correct here, but option A, B, C, both the three terms are also important. So let's discuss the remaining options here. So this is the chart, or this is the graph of stress strain curve or stress strain graph. Here stress is nothing but the internally applied force with respect to particular cross sectional area, and strain is nothing but a change in a length to original length or change in a cross section to original cross section. Okay, so on the x-axis there is an independent variable is mentioned which is strain, and on the y-axis there is a dependent variable is mentioned which is stress. Stress is in Newton per mm square and strain is unitless. Okay, so this graph is related to mild steel. अब ये ग्राफ माइल्ड स्टील के लिए हमने बनाया है, तो इस ग्राफ में बहुत सारे पॉइंट है A, B, C dash, C, D, E and F. Okay, so point A is known as limit of proportionality or proportionality limit, which is the point in which stress is directly proportional to strain, and that point is beyond which linear variation is ceases. After the point limit of proportionality, the linear variation is ceases, but up to point A, stress is directly proportional to strain, and up to that point, Hooke's law is valid. Hooke's law is nothing but the stress is equals to E into strain. That E is the Young's modulus, and stress is directly proportional to strain, and to equate the stress and strain there is a constant which is called as Young's modulus or modulus of elasticity, which is represented by E symbol and unit is Newton per mm square. Then next point is B, which is elastic limit. Elastic limit is the maximum stress in which original length regain. Okay, means up to point A and B, the original length or original whatever the shape of the mild steel is regained up to the point B, up to the elastic limit. So that's why the region from y-axis to point B is the elastic region, and up to this point we can regain the original shape or original length by removal of loading. Then next point is C dash. C dash is the upper yielding point. So yielding point is nothing but the point in which the material get deformed or material started to get deformed. Okay, that point is nothing but a yielding point, and C point is the upper yield point, means here the stress is maximum. Okay, in the C dash the stress is maximum as compared to C, which is lower yield point. Okay, and that upper yield point, the magnitude of stress is depend upon the cross section and the shape of specimen. Lower yield point, in that point yielding is also happen, but the stress is less as compared to C dash, means upper yield point, and that lower yield point is the actual yield point. Then after C, point D is formed. and the distance between C and D is perfectly plastic region. C and D, the region is perfectly plastic region. In that region, stress is constant, strain is increasing. Okay, plastic strain here is 10 to 15 times of elastic strain. Then after D, the point E is rises. Between D to E, that line here in the D to E, the stress is increasing. The stress is increasing, and that region is strain hardening. In that, strain is also increasing and stress is also increasing. And then next is E point, which is ultimate stress point, and the ultimate stress point is the maximum point of a stress, and the strain here is 20% of mild steel. Then after E, the point F is rises, which is fracture point, and the region between E and F is necking region, and in the necking region the cross section is drastically decreases. In that necking region, stress reduces with respect to strain. Then last point is fracture point, and that fracture point is nothing but a breaking point also, and the stress about that point is a breaking stress, and strain about that point is the fracture strain. Then the strain is 25% of mild steel. The strain whatever the strain is present here in the fracture point is 25% of mild steel. And from B to F, that region is called as plastic region. So this is all about the stress strain curve or stress strain graph, and all the points are important from this graph. Proportionality limit, A is the proportionality limit, B is the elastic limit, C dash is the upper yield point, C is the lower yield point, C to D is the perfectly plastic region, D to E is strain hardening zone, E is the ultimate stress point, E to F is the necking region, and F is the fracture point. Then second question, fixed end moments at A and B for the fixed beam shown in the figure subjected to indicated uniformly varying load are respectively. अब इस डायग्राम में एक फिक्स्ड बीम गिवन है और इस फिक्स्ड बीम पर एक यूनिफॉर्मली डिस्ट्रीब्यूटेड लोड गिवन है. Okay, so there are different conditions of fixed end movements with different loadings. So let's discuss the conditions one by one first. So first condition is fixed beam is in both condition the common thing is fixed beam, but the loading is point loading is at its center here in first condition, and in second condition the point loading is eccentrically applied here. So the fixed end moment for MAB and MBA, MAB is for first end or A end, and MBA is for B. So the movement at first end is negative because it is anti-clockwise, and at the second end is positive because this is clockwise. So remember, first column is negative and second column is positive. If the point loading is applied centrally, then the fixed end moment is minus WL by 8, and at B plus WL by 8. Then second, if point load is applied eccentrically, if we want to calculate the end moment at A, then take a square of B, and if you want to calculate the moment at B, then take a square of A. Okay, so here minus WAB square for A divided by L square, and second WBA square by L square. Simply यहाँ पर अगर आपको A सपोर्ट पर मूवमेंट निकालना है तो B का स्क्वायर लेना है, और B पर निकालनी है तो A का स्क्वायर लेना है. ठीक है, so this is the fixed end moment for point loads at its center and at eccentric region. Then second condition is with uniformly distributed load. So for uniformly distributed load, first condition minus WL square by 12, or for first end moment or at A point minus WL square by 12, and for second WL square by 12 plus WL square by 12. So this is most asked. This is the uniformly distributed load at mid region. So this is the formula for the MFAB. So that MFAB is minus WA square divided by 12L square in bracket 6L square minus 8LA plus 3A square. Then second for MBA plus WA cube divided by 12L square into 4L minus 3A. Then next condition, this is the fixed beam with uniformly distributed load for whole span, and that fixed end moment at MAB is minus WL square by 30, and for MBA is WL square by 20. Then this is the uniformly distributed load for mid region. Here this is A and remaining portion is L minus A. So this is the formula for MAB, and this is the fixed end moment for MBA. Then if uniformly varying load is in triangular position for whole span, then MAB is minus 5 divided by 96 WL square, and then second MBA plus 5 divided by 96 into WL square. Then last condition, in the last condition, fixed end movements or fixed beam with the movement at center, and here the movement is with the eccentric distance. So the movement for MAAB is m by 4, and for MBA is m by 4, here plus and plus on both sides. And for this movement also, MB in bracket 3A minus L divided by L square, and for second MBA, MA is equals to 3B minus 1 divided by L square. So these are the conditions for fixed end moments. Then question second, is fixed end moment for this uniformly distributed load. So as we see before, the fixed end moment for this uniformly varying load fixed beam is minus WL square by 30, or and for B plus WL square by 20. Then question third, the maximum slenderness ratio for a steel tension member is. For a steel tension member is. So this is the chart for slenderness ratio. Slenderness ratio is the ratio of effective length to radius of gyration. So the first condition or the type of member, a member in which reversal of stress due to the load other than wind or seismic forces occur. Other than wind or seismic forces, then maximum slenderness ratio is 180. Then second condition, a member acting as tie in a roof truss or a bracing system subjected to possible reversal of stresses due to wind or earthquake forces, the maximum slenderness ratio is 350. Then third condition, the tension members other than pre-tensioned. The tension members other than pre-tensioned are 400. In here they ask steel tension member, the maximum slenderness ratio is 400. Option C is correct. Then fourth question, the effective length of compression member shown in the figure is equal to. So there are different conditions related to effective length. So the effective length here for this, first the end is below end, or the first end is restraint for translation and rotation, and the upper end is restraint for rotation and free for translation. Then the effective length is 1.2 L. So this is the effective length chart of remaining condition, and if you want a video related to the effective length, there is one video on my channel that how to remember this effective length chart easily, and I think you should watch that video, and you can watch that video from my channel, or else I will put the link into the I section or in description. Then next question, the thickness of battens shall not be less than shall not be less than 1/50th of the distance between the innermost connecting lines of rivets, bolts or welds. Here option B is correct, and this is the important question. So the 1/50th of the distance between the innermost connecting lines of rivets, bolts or welds. This is the thickness of battens that shall not be less than 1/50th. Then next question, the thickness of T of a single flat lacing should not be less than 1/40th length between the inner end rivet, and for double flat 1/60th. This is also important. For a single lacing, T should not be less than 1/40th, and for double lacing, T should not be less than 1/60th. Option B is correct. Then the bond produced in a brick masonry by laying alternate headers and stretchers in each course is called as Flemish bond. In the Flemish bond there is alternate stretchers and headers. Okay, but the Flemish bond is divided into two types. First one is single Flemish bond, second one is double Flemish bond. In single Flemish bond, the front side is having the alternate headers and stretchers, and in the double Flemish bond, both sides has alternate headers and stretchers. So the proper answer of this question is double Flemish bond, but here they ask alternate stretchers and headers in each course. So the answer is double Flemish bond. Then these are the remaining bonds. First is stretcher bond. Here all the cores are formed by stretchers. Second, header bond. All the courses are formed with headers in front. And then this is the Flemish bond. Flemish is with single Flemish and double Flemish. Here the alternate headers and stretchers in each course. कोर्स मीन्स दिस लाइन. ओके, कोर्स क्या होता है? कोर्स मतलब अगर ये ब्रिक का लेयर हम यहाँ पे लगा रहे हैं, ये जो हॉरिजॉन्टल लाइन है, इस हॉरिजॉन्टल लाइन को हम क्या कहते हैं? कोर्स. और इस कोर्स में अगर सारे स्ट्रेचर्स हो तो ये होता है स्ट्रेचर बॉन्ड. अगर इस कोर्स में सारे हेडर्स हो तो वो होता है हेडर बॉन्ड. अगर इस कोर्स में एक स्ट्रेचर है, एक हेडर है, एक स्ट्रेचर है, एक हेडर है, तब इसे कहते हैं हम फ्लेमिश बॉन्ड. और इंग्लिश बॉन्ड क्या होता है कि जो ये कोर्स है, इस कोर्स में ये पूरा कोर्स हेडर्स का है, उसके बाद जो कोर्स आएगा वो पूरा स्ट्रेचर्स का है, उसके बाद जो कोर्स आएगा वो पूरा हेडर्स का है, उसके बाद जो कोर्स आएगा वो पूरा स्ट्रेचर्स का है. अगर ऐसे कोर्स आएंगे तो उसे कहते हैं हम इंग्लिश बॉन्ड. सो फ्लेमिश एंड इंग्लिश बॉन्ड बोथ आर द important condition and both are mostly used conditions. So these are the cuts of bricks which is used in the bond of bricks. So first is a full brick, second this is the half bat. If we cut it half by its length, then this is 3/4 bat, this is beveled bat, queen closure, king closure, this is beveled closure, and this is mitrade closure. So these are the cuts provided in the bond of bricks. So these all are important. So remember this. Then next, which of the following is true for project evaluation and review technique? PERT. PERT is project evaluation and review technique, which is true. Okay, so first of all, PERT is the event oriented. Okay, PERT is event oriented. CPM is critical path method, which is activity oriented. PERT is event oriented and CPM, critical path method, is activity oriented. Then second, PERT is a tool for planning. Then third, their time estimate are need. Fourth, based on probabilistic approach. And CPM is based on deterministic approach. Then fifth, cost is directly proportional time, hence minimum cost will be achieved to minimum completion of time. Sixth, suitable for a new type of project which not happened earlier. So here option A is correct because this is true about the project evaluation and review technique. It is event oriented and is a tool for planning. Option A is correct. Then next question number 9. In the stability of floating bodies, the stable equilibrium is attained if the metacenter M point dash the center of gravity. Dash the center of gravity means lies above, coincide with, is parallel to, or lies below. Before discussing the answer, let's discuss the condition of floating bodies and stability of submerged bodies first, or what is the metacenter and buoyancy point and center of gravity. So first, metacenter. Metacenter is the point about which a body start oscillating. About which body start oscillating when the body is tilted by some angle. If body is tilted by some angle, then body start oscillating. That point is metacenter, and it is the point where the line of action of buoyancy will meet the normal axis of the body when the body is given a smaller angular displacement. Okay. Then stability of floating bodies. There are three conditions. First, stable equilibrium, next unstable, then neutral. If there is stable equilibrium, then metacenter is above the center of gravity. If unstable, metacenter is below the center of gravity. And if neutral, then metacenter and center of gravity lies at a same position or coincide with each other at same point. Stable, metacenter above, unstable, metacenter below, and neutral, metacenter coincides with the center of gravity. Okay. Then next condition, the stability of submerged bodies. Okay. First condition is related to stability of floating bodies. Related to stability of floating bodies. In floating bodies, stable, metacenter related, and in case of submerged, it is related to center of buoyancy. For stable equilibrium, the body, the center of buoyancy is above the center of gravity. Center of buoyancy is above the center of gravity, then it is a stable equilibrium. Then next condition, unstable equilibrium, center of buoyancy is below the center of gravity, then unstable equilibrium. In neutral, the center of buoyancy is coincides the center of gravity. Okay, so these are the three conditions related to the submerged body, stability of submerged body. In case of stability of floating body, there are three conditions. First is stable, second unstable, third is neutral. In case of floating body, we consider metacenter. If metacenter is above the center of gravity, then stable equilibrium. If metacenter is below the center of gravity, then unstable equilibrium. Is metacenter coincides with the center of gravity, then neutral equilibrium. And in case of stability of submerged body, first condition is stable equilibrium. In that, the center of buoyancy is above the center of gravity. In case of unstable equilibrium, center of buoyancy is below the center of gravity. And in case of neutral equilibrium, the center of gravity coincides with the center of buoyancy. So this is the question number 9. In the stability of floating bodies, the stable equilibrium is attained if the metacenter M point lies above the center of gravity. So option first is correct here. Then next question number 10, and this is the important question. So specific gravity is defined as the ratio of Mass of solid to the mass of equal volume. Mass of solid to mass of equal volume of water at 4 degrees Celsius. At 4 degrees Celsius. So option D is correct. First question. The room temperature stress strain curve of four materials P, Q, R and S are shown in the figure below. The material that behaves as a rigid, perfectly plastic material is. So this is a graph, and in that graph they ask which graph is behave as a rigidly plastic material. So for that graph, this is the chart, and from this chart the rigidly perfectly plastic material, the graph is parallel to strain axis, and that axis is a horizontal. So here S is behaves as a rigid perfectly plastic material. So option number 4 is correct. And the graph for ideally plastic material is first initially the graph in that graph stress is directly proportional to strain, and next the stress is constant and strain is increasing. Then for perfectly rigid body stress increases, strain zero. Then for nearly rigid body, this inclined line is this graph for stress strain curve. Then for incompressible material, the stress is zero and strain is increasing. Then the stress strain curve for non-linear elastic material is straight initially, means stress strain are proportional to each other initially and then form a curve like structure, and these are the examples for these different types of material or a body. Then question number 2. A village has a population of 200 with an average rate of water demand of 100 liters per capita per day. A rapid sand filter having an average filtration rate of 100 liters per hour per meter square is to be designed for water treatment. The area of rapid sand filter required is. So for area of rapid sand filter, formula is design discharge to average filtration rate. Okay, so first write down the given data. So in the given data, the ratio of maximum demand to average demand is 1.5. So village population is 200, then average rate of water demand is 100 liters per capita per day, then average filtration rate is 100 liters per hour per meter square. Convert it into a liters per day per meter square by multiplying 24. Then ratio of maximum demand to average demand is 1.5. So this is the formula to calculate the design discharge. Design discharge is 1.5 into village population into average rate of water demand. So this is the design discharge, and average filtration rate is given. So the area of rapid sand filter is 12.5 meter square. So option third is correct. Third question. Consider the following statements regarding the slope of cost time curve. First option is it is given by difference between normal cost and crash cost divided by crash time. Then second, it is given by difference between crash cost and normal cost divided by difference between crash time and normal time. Third, it is given by difference between crash cost and normal cost divided by normal time. And last is given by a crash cost divided by crash time. Okay, so this is the graph for a cost slope, and in that x-axis is belongs to time, y-axis is belongs to cost, and cost slope is nothing but the slope of this straight line. Cost slope, the formula is given as the crash cost means cc minus normal cost means cn divided by normal time minus crash time. Okay, so this is the formula, crash cost minus normal cost divided by normal time minus crash time, and this cost slope is approximately a straight line, and slope of that straight line is nothing but a cost slope, and which is very helpful in the project cost analysis. So in this question, option number second is correct. 2 only, means it is given by difference between crash cost and normal cost divided by difference between crash time and normal time. Fourth question, d by tw is less than or equal to 400 epsilon w, where epsilon w is square root of 250 divided by fy. Then if d is a depth of wave and tw is the thickness of a wave of plate girder such that. So these are the options. So here in the case of plate girder, the ratio of d by tw knows about the are used to know about the stiffness. So if d by tw ratio is less than or equal to 400 epsilon, then end bearing stiffness, intermediate transverse stiffness, longitudinal stiffness at point 2d from the compression phase and at the neutral axis are needed. Okay, so here option number third is correct. If that ratio of d by tw is less than 67 epsilon, then unstiffened girder can be designed, that is no girder is required. If that d by tw is greater than 85 epsilon but less than 200 epsilon, then vertical stiffness C1 and C2 may be provided. If d by tw is greater than 200 epsilon but less than 250 epsilon, then vertical stiffness along with the longitudinal stiffness at point 2d may be provided. If that d by tw ratio is greater than 250 epsilon and less than 455 epsilon, then vertical stiffness along with the two longitudinal stiffness at point 2d and point 5d respectively may be provided. So for this question, option number third is correct if the ratio of d by tw is less than or equal to 400 epsilon w. Fifth question, if an activity has its optimistic, most likely and pessimistic time as 2, 4 and 9 respectively, then its expected time and variance are. So the expected time formula is TO plus 4TM plus TP divided by 6, and that TO is optimistic time, TM is the most likely time and TP is the pessimistic time. So expected time is TO plus 4TM plus TP divided by 6. By putting the given values into this question, the expected time is 4.5 and standard deviation formula is S is equals to TP, means pessimistic time minus optimistic time divided by 6, which is equals to TP is 9 minus TO is 2, so 7 by 6. As variance is a square of standard deviation, so variance is 49 by 36. 7 square is 49 and 6 square is 36. So variance is 49 by 36 and expected time is 4.5. So option number C is correct. Then sixth question, on a ladder resisting on a smooth ground and leaning against a rough vertical wall, the force of friction acts. Okay, so in this question, the ladder resisting on a smooth ground. Okay, so this ground is a smooth and leaning against a rough wall. Okay, this is rough wall and this is the ladder. If the surface is smooth, if this surface is smooth and this wall is rough, then this ladder is slipping in this direction. Okay, and from the wall it sleep in downward direction. So to support that sleeping of this ladder, there is need to be a force of friction which is upward at its upper end. Okay, so the force of friction is like this. So upward at its upper end, this is the force of friction for this condition. Then question number 7. As per the Indian standard IS 800-2007, the partial safety factor for material resistance governed by yielding failure of steel is. So here they ask a partial safety factor for the yielding failure. So for yielding failure, the partial safety factor is 1.1. Then for buckling also, the partial safety factor is 1.1. Then in case of ultimate stress, partial safety factor is 1.25. In case of connections, there are two type of connection. First is shop, second is field. And in the shop and field, there is a bolt of friction type, bolt of bearing type, rivet and welds. All the partial safety factors are 1.25 except the weld in case of field fabrication, that is 1.5. Okay, so the option number first is correct for this question. Then eighth question, as per the IS 456-2000, when HYST bars are used, the minimum reinforcement in either directions of the slab is. Minimum reinforcement in case of HYST are 0.12% of total cross section area, are 0.212% of total cross sectional area. And in case of mild steel, means in case of Fe250, that percentage of percentage of minimum reinforcement in the direction of slab is 0.15% of total cross sectional area. So for HYST 0.12% and for Fe250 mild steel 0.15%. Option number B is correct. Ninth question, as per IS 10500 2012, the permissible limit of total dissolved solids (TDS) in mg per liter in drinking water in the absence of an alternate source is, and that TDS in the drinking water in the absence of alternate source is 2000. These are the various permissible limits for the different parameters, and for TDS of the drinking water in the absence of alternate sources 200, 2000, and acceptable limit is 500. Total suspended solid is 500 and permissible limit in absence of alternate source is also 2000. These are the remaining parameters of various permissible limits for the different parameters, and these are the total suspended solids, turbidity, color, taste and odor, TDS, alkalinity, pH, hardness, chloride content, free ammonia, nitrate, fluoride, iron, sulfate and calcium. So here option 4 is correct. 10th question. As per building bylaws, for fixing up the height of a building, which rule is generally used? This is simple question, and the rule of 63 1.5 rule is used to fix up the height of building. So option first is correct. Then question number 11, 0.2% proof stress means 0.2% proof stress means. So 0.2% proof stress is an indicator of yield stress. If we apply some kind of a loading on any steel body, then it change its shape due to application of loading, and if we release that stress from the body, it regain its original position, but there is some value exist which is beyond that stress, and upon release of that stress, original dimensions are not recovered. Okay, and that remained stress in the body is nothing but a stress at which if unloading is made, there will be a 0.2% permanent strain. Okay, so there is 0.2% of permanent strain is always there in the body. So 0.2% proof stress means stress at which if unloading is made, there will be a 0.2% permanent strain. Option C is correct. What is the mechanical extra widening required for a two-lane pavement of width 7 meter on a horizontal curve of radius 250 meter if the longest wheelbase of a vehicle expected on the road is 5 meter with a design speed of 70 kmph is? So first, formulas to calculate the extra widening are WE is equals to WM for mechanical widening and WPS for psychological widening. So for mechanical widening, formula is NL square divided by 2R, and for psychological widening the formula is V divided by 9.5 square root of R. So by adding the mechanical widening and psychological widening, we get extra widening of road. Okay. So here N value is 2 lane pavement, L is 5 meter, R is 250 meter, V is 70 kmph. Mechanical widening is equals to NL square by 2R. By putting the values, we get the mechanical widening as 0.1 meter. So option number 13th question. Which of the following relations are correct for determining the different components of bid prices? So first, bid price is equals to direct cost plus indirect cost plus markup amount. So direct cost plus indirect cost is nothing but a base cost, and bid price is equals to base cost plus markup amount, and first option is correct. Then markup amount is equals to profit plus contingency plus allowances for risk plus general overheads. So this markup amount is also correct. But in case of direct cost, this option number second is incorrect. For direct cost, the addition of labor cost, plant and equipments cost plus material cost and subcontractor cost all are added in the direct cost. Okay, so option number first and third is correct. So this is the direct cost, labor cost plus plant and equipment cost plus material cost plus subcontractor cost. Option number third is correct. First and third only. Next question. As the depth of immersion of a vertical plane surface increases, the location of center of pressure. This is the formula for the center of pressure. H is equals to x bar plus Ig divided by Ax bar into sine theta square. So for vertical plane surface, as mentioned in the question, the theta for the vertical plane surface is 90 degrees. So sine 90 is 1 square is 1. So H is equals to x bar plus Ig divided by Ax bar. As in the question, the depth of immersion of a vertical plane surface increases, means x bar increases, then the location of center of pressure, means H is. If x bar increases, as usual H increases, but the x bar is also present in the denominator, that Ig divided by Ax bar. So because of that, the depth of immersion of a vertical plane surface increases and the location of center of pressure falls closer to the center of gravity of the area. So here option number first is correct. Then last question. Choose the incorrect characteristic of a contour from among the following. First is a watershed line cross the contours at right angle. First is correct. Then second, the direction of steepest slope is along the longest distance between the contours. So option number second is incorrect, because for the steepest slope the distance should be shortest. Then third option, two contour lines touch in the case of vertical cliff. Correct. In the direct method of contouring, the contours are not interpolated. This is also correct. So here option number second is incorrect option, but for this question option number second is correct. So these are the 15 questions in the part second of BMC practice question. So on this slide there are two questions. So these questions are up to you. Comment the answers of these questions before next video, and thank you. Question number 1. The kinematic indeterminacy of the following beam after imposing the boundary condition is. To calculate the kinematic indeterminacy, formula is 3j minus in bracket r plus m, where j is the number of joint, r is the number of unknown equations, and m are the number of plastic hinges equation. To calculate this number of plastic hinges equation, first we need to calculate the number of members meeting at the hinges, then subtract -1, then subtract 1, and we get a number of plastic hinges equation. Then as per the above diagram, the number of members meeting at the hinge are 5. First this AE member, then second EB, BF, then FC, then CD. Okay, these are the 5 members. Then number of joints are 7. First, second, third, fourth, fifth, sixth, and seventh. The number of unknown equations are, for the fixed beam there are 3 reactions or 3 unknowns, then for the roller 1 unknown, then for hinge there are 2 unknowns, and for spring there is 1 unknown. So by calculating all the unknowns from the supports, the number of unknown equations are 7. So putting all the values into the formula, we get dk means kinematic indeterminacy as 10. So option number 3 is correct here. Then second question, a fixed beam AB of constant EI shown in figure below support a concentrated load of 10 kN. What is the fixed end moment MFAB at support A? Okay, so here a beam is given, a fixed beam is given with 5 meter of span and a 10 kN of load which is eccentrically applied on this beam. Okay, so here from this to 10, the distance is 2 meter. So remaining distance up to this fixed support is 3 meter. Okay, to calculate the fixed end moment, formula is for MFBA. For MFBA, formula is PA square B by L square, and for MFAB, the formula is minus of PAB square by L square. Okay, so by putting the values of A and B, so A is from first support to load, and then B is from load to second support. Okay, so here A value is 2, B value is 3, P is 10 kilonewton, and L is 5 meter. So the value of fixed end moment, that is MFBA, is 7.2 kilonewton meter. So option 3 is correct. Then question 3, the sinking moment in the prismatic fixed beam whose one support yields by delta will be where L is the length of beam, I is the moment of inertia, and E is the modulus of elasticity. So this is the first condition. They ask one support yield by delta will be in the fixed beam. So condition, if there is a fixed beam and one support is yield by delta, then the value of sinking moment is 6 EI delta by L square. So option 3 is correct here, and this is the remaining condition, second condition. In that condition, one end is fixed and other one is pin, and there are both conditions if pin is settled down and if fixed support is settled down. Then question 4, which principle can be used to obtain the general shape of influence line? So the principle is Muller's Breslouis principle. Then next, question number 5. Generally, a dose of 2 to 3 ppm beyond breakpoint is adopted in case of superchlorination. So the dose of 2 to 3 ppm residual is adopted in case of superchlorination, and which is mostly added at the end of filtration. Then next, in case of breakpoint chlorination, the extent of chlorine added to water beyond which any further additional chlorine will appear as a free residual chlorine. And in case of pre-chlorination, the application of chlorine to the water before filtration, or rather before the sedimentation and coagulation, and the normal dose of chlorine is 5 to 10 mg per liter. Then next, in case of post-chlorination, post-chlorination is a normal process of applying a chlorine which is at the end when all the other treatments are completed. And then double chlorination, it is simply means that the water has been chlorinated twice. So here the question number 5, option first is correct, that is superchlorination. Then next, the super elevation is, question number 6, the super elevation is directly proportional to which criteria? So super elevation is E represented by E, and formula for that is E plus F is equals to P by W equals to V square by GR in case of meter per second, if velocity is used in case of meter per second. Then next, E plus F is equals to V square divided by 127 R. Here V is in kmph, kilometer per hour, where F is the coefficient of lateral friction, which is 0.15, R is the radius of horizontal curve. So by observing the formula, we know that the super elevation is directly proportional to the velocity of vehicle. So option first is correct here. The next, design of pins is primarily governed by, design of pins are primarily governed by flexure. Okay, so pins are a large bending movements which are generated since members joined by pin connections are separated by some distance, and pin diameter is generally governed by flexure. The amount of load transferred through the joint will determine the size of bolt and the plate thickness. Okay, so basic criteria, what's the flexural strength? Flexural strength is nothing but a bend strength, and which is defined as a material ability to resist the deformation under load and measure in terms of stress. Okay, so for question number 7, the option C or option third is correct, that is design of pins is primarily governed by flexure. Then question number 8, the imperfection factor for welded connection or for welded steel section is. So for this imperfection factor, there is a one table in IS 800 2007, and from that table we take a value of imperfection factors for the welded steel connection, and that value is 0.49. Okay, here this is the table from IS 800 2000, IS 800 2007, table number 7, and these are the values, and this C is used for the welded steel connection. Then question number 9, if S is the shear strength, C and phi are the shear strength parameters, and sigma n is the normal stress at failure, then Coulomb's equation for shear strength of soil can be represented by. So Coulomb's equation is written as S is equals to C plus sigma n tan phi. S is equals to C plus sigma n tan phi, where S is the shear strength, which is equals to C and phi are the shear strength parameters. So C plus sigma n is the normal stress into tan phi. So here they ask in term of C and S. So C is equals to S minus sigma n tan phi, where C is the apparent cohesion on normal stress and phi is the angle of internal friction. So option second is correct here. Then slope of truss is equal to. So slope of truss is equals to 2 times of pitch. So in case of roof truss, they are economical for the span which is more than 6 meter. If the span is more than 6 meter, then they are economical, and the pitch of roof truss, that is rise or span, should be 1/4 to 1/6 to its slope for the proper drainage, and the slope is equals to 2 times of pitch. The spacing of the roof trusses is kept as 1/3 to 1/5 of the span. A minimum angle section, which is ISA 50 by 50 by 6 mm, should be provided to avoid the damage during the transportation. So here the option number C is correct, that is 2 times of pitch. Then question number 11, in columns splices should be provided at. So splices should be provided in case of column are 1 by 4th of height of columns, are provided at 1 by 4th of height of column. Okay, so location of splices is due to direct load there are 2 points of contraflexure which are varying from. So point of contraflexure is that point where the bending moment changes its sign from positive to negative or from negative to positive. Okay, so for direct loading there are 2 points of contraflexure varying from the middle of the column to the points above or below the middle, which will be about 1/4 of the height of column. Okay, so in case of column the splices are at 1/4 of height of column. So what are the column splices? A splice is a joint provided in the length of member, and in case of column splice, if the load is truly concentrated, then theoretically no splice is required in case of compression, while it will be provided directly and transferred through the bearing. But truly axial load in the column never occurs. Okay. Then in the column section, column sections are required to be placed for the following cases: when the available length of structural steel section is less than the required length of column, when the available length of structural steel section is less than the required length of column, and if the case of multi-story building, then we provide column splices which are 1/4 of height of column. Then next question, which of the following method is recommended by IRC for design of flexible pavement? For design of flexible pavement, the method which is recommended by IRC is CBR method. Okay, CBR method. CBR method is a group index method of design of flexible pavement, has been obsolete nowadays, and this CBR can be defined as the ratio of load at penetration of 2.5 mm or 5 mm. That is, for 2.5 mm penetration, load is 1370 kgs, and for 5 mm penetration, load is 2055 kgs. This is also an important question. They ask sometime what is the loading for the 2.5 mm penetration in case of CBR method. So options are 1370 and 2055. So you can select a correct option for this penetration. For 2.5, 1370, and for 5, 2055. Okay, CBR is inversely proportional to the thickness of pavement. CBR is inversely proportional to thickness of pavement. Observe carefully. In each of the explanation there is one MCQ. So listen carefully, write it down and revise it. Then next question, the cavitation damage in turbine runner occurs. The cavitation damage in turbine runner occurs near the outlet of the convex side of blades. Occur near the outlet of convex side of blades. So option second is correct. Then coefficient of annual sinking fund IC can be determined by. So IC is determined by IC is equals to I divided by 1 plus I raised to n minus 1. IC is 1 I divided by 1 plus I raised to n minus 1. The next question, which of the following method is also called as out to out and in to in method? So out to out and in to in method is long wall and short wall method. So long wall and short wall method is also known as out to out and in to in method, or to separate or individual wall method. The length of long wall usually decreases from earthwork to brickwork in superstructure while the short wall increases. Okay, remember this also, that length of long wall decreases from earthwork to brickwork. Okay, and length long wall length out to out is a center to center length plus half breadth on one side plus half breadth on another side. The next, short wall length in to in. Long wall is out to out and short wall is in to in. Okay. Center to center length minus half breadth on one side and minus half breadth on another side. Option first is correct. Then question number 16. If h is the height of If h is the height above datum of object and capital is the flying height above the datum and small r be the radial distance of the image of the object from the principal point, then the relief displacement d is. The relief displacement is d is equals to small r into small h divided by capital H. Okay. So option first is correct. The next, Bernoulli's equation is derived making assumptions that. So here they ask assumptions which is related to Bernoulli's equation. So assumptions are the fluid is ideal, that is viscosity is 0, means non-viscous. Then next, flow is steady, then flow is incompressible and flow is one dimensional. So here by observing the option number third is correct. Steady, non-viscous means zero viscosity, incompressible and irrotational. Option third is correct. Then question number 18. The free mean speed on a roadway is found to be 70 km/h under stopped condition. The average spacing between the vehicle is 5 meter. The capacity of flow is. Formula to calculate the capacity of flow is Qmax is equals to kj by 2 into uf by 2 vehicle per hour. Okay, so here free mean speed is given which is in kmph, 70 kmph, and average spacing is given which is 5 meter. So for calculation, the average spacing between vehicle is 5 meter. Jam density which is kj equals to 1000 by 5, and then free mean speed qf is 70 kmph. So for flow velocity maximum, 70 into 200 divided by 4, and that 70 into 200 and that 2 is 4 here. So the value of flow capacity is 3500 vehicle per hour per lane. So here option number first is correct. Then next, the distribution factor for BA member in the given figure is. For BA, the distribution factor for BA in the member is given, and that distribution factor is. For calculating the distribution factor, there is one formula for DKBC. For DKBC, for BC, the KBC by KBC plus KAB, and for DKAB distribution factor for AB, the KAB divided by KBC plus KAB. Okay, so stiffness of member AB, that is K, is a stiffness. Far end is fixed. If far end is fixed, KB is equals to 4EI by L, and stiffness of member BC, far end is hinged or roller, then KBC is equals to 3EI by L. If the far end is fixed, then stiffness is 4KEI by L, 4EI by L, and if far end is hinge, then stiffness K is 3EI by L. Okay, so for fixed 4EI by L and for hinge 3EI by L. By putting the values in the formula, the DKAB is 4 by 7. So option second is correct.